So we are now on the last lesson for Curvilinear translation that is about banking of highway curves. So the root word here is banking. By the end of this lesson, you will be able to apply the principles of dynamic equilibrium in solving and analyzing the kinetics of a vehicle rounding on a banked curve. So why do we need to quantify a vehicle that is crossing on a bank curve? So first is that not all pavement straight. So dili man straight tanan, naagi mga areas or locations that we need to have a curvature sa ato ang pavement or sa Bisaya pa kalsada. So dili magina tanan straight, naagi mga curvature. And that curvature gi-calculate na siya, di na ingon nga kurbada-kurbada lang kay if ang kanang curve if kanang curve kay nana siya consequences if that curve kay plane lang or naka-incline ang iyang outer with respect to the inner. So nag-wonder pod mo, ani pod nga second picture, no? Ang car nga naa sa kanang closer sa curve, ang surface sa iya pavement is almost flat whereas as the radius of curvature, ang kalikuon sa kalsada nagka-increase sa sinuti sa kaning katulong nga car, ang iya surface is naka-angled na with respect to the horizontal. So naa siya significant kung ano na siya significant effect with respect to the stability ug balance sa ato ang vehicle. Kay if wa na siya inclination dira ang chances ni ani is that motip over ni siya or mawagtang sa kalsada, like mabalintuwad ni siya, okay, and that would result to an accident, okay, mo na siya gi-prevent ni ani. And then of course this one is very popular sa kanang mga mag-rides every Sunday, ng atong mga kuan, mga riders. So there is a science behind this one, this picture, nganong ang kaning kuan motorist, iya gipa-incline ang iyahang motor vehicle with respect to the horizontal if mag-perform siya or mo undergo siya og kanang curve, kurbada gali mo na iya buhaton. So iya gibuhat in order to counteract the centrifugal force, remember sa ato previous nga lesson, if an object is traveling a curved path, if this is our object, let's consider this one as a particle. So this curved path has a center of curvature, right here. So there's a radius r. So ang force nga may act niya towards the center is known as the centripetal force. And then of course ang balance niya is the centrifugal force. So if the object cannot resist, or if the orientation of the object cannot resist the centrifugal force, then what happened is that this particle moon sa naman siya, mawagtang siya sa iyahang circular path, musukway siya, malabay siya dira, okay, malabay siya pa outward. So naay reason ni ani mao nang ang bank curve, when we say banked, kanang naka-inclined ni siya. So instead of the normal curve nga pa flat, kung mag-bank curve ta, there is an inclination. Okay? Nata inclination. Okay? So if ever gali ang ato ang curve or ang kumbada or ang kurbada walay inclination, so that's not the time, especially sa mga motorista, ang ilahan ng motor may gipa inclined, para di sila malabay. So again, on some roads, nga naay inclination, so tawag ana term na ilang gibanked. So ang purpose sa banking is that it reduces the chance of skidding the vehicle as it take a sharp turn on a curved pavement. Okay? So In other or in simple terms, para malikayan ang aksidente no nga malabay siya, okay? Malabay siya sa dalan. So naay duha ka klase sa banking. The first one is the ideal condition. So the ideal angle of banking wherein ato gi-assume nga walay friction nga nag-exist between the road and the tires of our vehicle. And the second one is the actual condition or the actual angle of banking. So we considered here the effects of friction that exist between the road and the tires. And this one is the ano, this one is the tool that is useful in a real scenario. Kay sa real scenario, of course, nagan ang friction. Kay luoy po kay walay friction ang atong tires, no? Di ta maka move. But of course, we still need to use the first type, the ideal angle of banking, because this is the basis of comparing the actual and the ideal results. So let's start with the first type, that is the ideal angle of banking, wherein we neglect the effects of friction, no? So ato ikuan diri no? Ato kitaon diri kung unsay nagpapugong sa ato ang vehicle from overthrowing sa iyahang path, no? Or from skidding, no? Para di siya malabay sa curve, sa kurbada. So unsa may nagpapugong niya? So we're going to perform an analysis. So first, let's consider a curved path nga naka-bank siya or naka-incline siya with respect to the horizontal. Inclined at an angle theta as shown in the figure. So next, let's have this typical vehicle. And then we are going to assume that our vehicle as an object, ato siya i-assume as a particle, no? Wherein that particle is located at its center of gravity, CG, kaning block, kaning kuan solid nga block. Okay? So, syempre, to do analysis, no? We need to know those external forces that acts our vehicle. So, the first one is obviously its own weight W directed downwards. What else? So, since our vehicle is kanang traveling in a circular path, no? If we take the top view of this figure, yan na siya. So na siya curvature, then this is our vehicle. So therefore na siya curvature. And again, the force that pulls this object towards the center is the centripetal. But if we analyze this one in a dynamic equilibrium condition, we consider the equilibrant force, no, or the reverse effective normal force, or we call that one as the REFN during our previous discussion. So the REFN, that is also known as um, the centrifugal. So when we say centrifugal force, that is away from the center of rotation. Okay, so the centrifugal force or the reverse effective normal force is equal to the weight times the normal acceleration, wherein the normal acceleration is equal to v squared over r. Okay, so again, it acts away from the center of this curve. So aside from this, of course, since ang ato ang vehicle kay ni rest at the road, so therefore ang road, of course, by Newton's third law, dapat siya normal force. And that normal force is inclined, no, with respect to the vertical axis by an angle of theta. Now, if we have these forces, external forces, no, we are going to isolate these forces, no, so that we can create a uh, a polygon, no, a polygon that would represent the forces that acts our object. So the first one is the weight, no, the weight. Okay? So by the way, ang kani siya mga forces, these are enough no to to conclude nga kanang dynamically equilibrium na ang ato ang object. Okay? Dynamically equilibrium na ang ato ang object. So again, if ato i-isolate ang mga forces nga nag-interact sa atong vehicle, so we have first the weight, then the centrifugal force, no? The centrifugal force acting towards the right, because kaning centrifugal force mao ni siya ang main nga factor no nga unsa man makapa-skid sa ato ang vehicle, makapalabay sa ato ang vehicle away from the road, away from the curved road, no? Maunang naa siya inclination kay unsa may nagpa-resist aning ato ang centrifugal force, our normal force. So with the help of this normal force and some help of the weight of the object, or the weight of the vehicle, then ato mapugnan no nga malabay ning sakyanan kung mo liko ni siya o kurbada kaayo. So aside from the centrifugal force, the last one is the normal force. Again, the angle between the vertical and the normal force, that is angle theta. And with this, we created a force polygon, a triangular force polygon. So from this force polygon, we can create a relationship no that exists among some important parameters. So if we take the tangent of this angle, no, if we take tangent theta, so that is opposite, that is the centrifugal force all over the weight. And then the centrifugal force is just the weight times the normal acceleration, no, all over the weight, makancel si weight. So therefore, for an ideal angle of banking, the tangent of theta is just equal to v square all over gr. Now, mag-add ta diri og subscript sa ato ang velocity, ato lay denote as r. So later, ato na ikuan unsay pasabot anang vr. So again, the theta here is the ideal angle of banking. So if may problem nga pangitaon ang ideal angle of banking, use this general formula. Okay? Meaning, ang angle does not depends upon the weight of the vehicle. It depends upon its speed and also the radius of the curve. No? The radius of the curve pavement. Okay? And then the velocity v under this condition is termed as the rated speed of the curve. So, the rated speed, i-abbreviate siya as VR. So, pasabot aning VR, rated speed. Meaning, more na siya ang minimum speed nga required nimo no nga para dili ka malabay sa kalsada, okay, or to prevent the vehicle from skidding. Now, if you exceed that value, no, if you exceed that value given that there is no friction nga na involved, so ang mahitaboan na is madisgrasya na ka no. So mao nang malabay na ka sa kalsada. Okay? So mao nang syempre in reality if mag-drive ta dili man din ta wala man tay calculator nga to no? Di man ta makasolve dayon. So ang buhaton nimo so that di ka maaksidente kung mo take turn ka, yung buhaton syempre mo brake gyud ka no. So that ma-minimize nimo ang imong velocity, no? Ma-minimize nimo ang velocity, imong rated speed, and thereby reducing the effect of the centrifugal force. That's the only way because magamit pa kaani nga mga formulas no in practical, syempre mo kay calculate ngadto, especially kung makalimot ka ani, no. So mara gyud una gyud imong pababa nimo hang velocity. If you lower the velocity, then you can reduce the effect of the centrifugal force. So safe ka sa sa skidding, no. Di mahitabo ang skidding. But of course, if you are going to design vehicle and also a curve pavement, then you're going to use these tools, this formula. Okay, so let's proceed to the actual, no, wherein we consider the effects of friction. Of course, namin gini sa actual, may tabo man gid ni. So again, same illustration, but ang difference lang ani is that ato na gi-consider diya ang effect of friction. So again, may naagihapoy weight no sa car or sa vehicle, and then the reverse effective normal force, or we call this one as the centrifugal force. And then our normal force, no, wherein mo na ang force nga gi-exert sa kani ato ang inclined road sa ato ang car, naka-angle na siya with respect to the vertical axis. And then since ang ato ang gi-prevent diriya is from skidding this car away from the center of the curvature, so paana ang ato ang assumption ani nga di siya mo makuan, no, di siya kanang maaksidente, no, di siya mo move pa outward. So ang ato ang direction sa friction ani, since ang friction kay mo resist man na siya movement, so therefore opposite siya sa atong kanang gi-assume nato nga direction sa kung maaksidente ni ato ang sakyanan. So the force is towards towards the lower part of our inclined road. So that is that is the frictional force represented by letter F. And then the resultant of this normal force and the frictional force is the R, no? Wherein again, the vector R is equal to the sum of the normal force vector plus the frictional force vector. And then the angle between the resultant force and the normal force is ato na siya represent as angle phi. Okay? So ato din ni siya ibalhin kani siya kanitong gisuwat kay namo din na dry mabutang taod-taod nga text. Kaya ato siya isuwat diri again, the resultant vector is equal to the sum of the normal vector and the frictional force vector. Okay? So again, let's isolate na pod sa mga external forces nga nag-interact. First, we have the weight, then we have the centrifugal force, then the resultant force this time. But again, from the figure, the resultant vector force can be expressed as the sum of the components of the normal force, motion N, and the frictional force F. Okay? So how about the angles? So the angle between the weight and the resultant force is the sum of the angle of bunking. So again, theta here is the angle of bunking, whereas phi is the angle of friction. So don't forget that one. Phi is the angle of friction. So perminti na mo ani nakasugat katatong review sa tong statics o sa previous pod sa rectilinear translation. So next, ang angle again between the normal force and the resultant is the angle of friction, and then the normal force with respect to the vertical axis is the angle of bunking. Now, ato na pod pangitaon ang relationship among these given parameters. So from the triangular force polygon, let's consider na lang this triangle W, and then the centrifugal force and the resultant. So naka-form gihapon siya og right kind triangle. So we can use the basic trigonometric identities wherein the tangent, no, the tangent of the angle phi or the angle of bunking plus the frictional force, I mean the angle of friction, is equal to the centrifugal force divided by the weight, no? So therefore tangent of theta plus phi is equal to WV square over GR all over W. So makancel si W. We have tangent theta plus phi equals V square over GR. So ato siya i-denote as M. So naanay meaning anang VM kanang gikuha na siya VM. So again kani siya is away from the center, no? Away from the center. It's because if atong assumption is that naman say possibility class nga tungod kay kanang hinay ra kayo ang imong speed, no? Hinay ra kayo imong speed, there's a possibility nga maunsa po ka matapple down po ka in this direction, no? Meaning maligid po ka sa inclination sa ato ang kalsada. So if that is the case, then ang ato ang equation mabaliktad. I mean, nalay mo modify gamay wherein angle of banking instead of mag-add ta sa iyahang angle of friction, ato siya i-subtract which is equal to again Vm square all over GR. I think the second equation is this is the minimum, and then the above equation, this one is the maximum. Okay, so this is towards the center, no? Towards the center. So kindly take note na lang ni ini. So again, sa actual nga angle of banking, you know, uh, still kuan siya, independent siya sa weight sa ato ang vehicle, no? Nagmatter gud siya sa again sa angle of friction, meaning this is kanang dependent on the type of pavement, no? Kabatuhon ba, asfalto ba, or ang sa man ang condition sa imong tires, like napabay mga spikes or wala na. Okay? And also, of course, di gid makalimtan ang speed nimo og ang radius of curvature of our curve path. So again, angle of V here, don't forget, this is the angle of friction. The theta is the angle of banking. And then the velocity V under this condition is greater than the velocity from the previous slide, katong rated velocity. That is why it is termed as the maximum speed. So, mo na imong maximum speed, no? In a real scenario, if you exceed this maximum speed, then madisgrasya na pug ka. Okay? And then, napot tay minimum speed, no? Di po ka pwede maginahinay pug ka, labi na og ang kurbada kay very inclined kaayo, okay lang if dili ka siya inclined ka pa maayo. If inclined siya, ay lang kay pag patugag pahinay kay maligid pug ka paubos, di ka maligid pababaw. Okay? So, asa man nato ang basis ani pag-design? You can have the rated speed, no? You can have the rated speed because the rated speed is below the maximum speed, no? Below siya. So, kung mag-design ka nga mas below pa sa rated speed, mas maayo kay mas safety siya. Kay if ang imong design is beyond the rated speed pero below pod sa maximum speed, no? Murag critical na siya, but if ang imong design is beyond the maximum speed, no? Gikuha na gud, no? Gi-include na gud ang effect sa friction, then dako na gyud nag-chance nga makuha na gyud ka, madisgrasya. Okay? So again, ang factor ani no nganong mura tag malabay palayo sa curve path is due to the effects of the centrifugal force, no? So unsa may nag-counteract ani niya in the actual scenario, nanatay duha ka buk mga parameters. First is the normal force, no? Due to the inclination of the road, and also the frictional force. So this force exists between the surface of the road and the tires. Mao nang daghan pag spike sa imong ligid sa sakyan na dili pahilis, then maka-resist pud na siya og centrifugal force para dili malabay imong sakyanan. Pero og hilis na kaayo, ang imo lang way ana is the normal force and some small amounts of frictional force. Okay? So, mo siya ang analysis sa banking. Now, proceed ta sa mga problems. So, wala ba'y pangutana so far? Sa katong mga formulas? Hello class, nakasunod paghapon? Wala ra? How about the others? Nakasunod ra? Okay, so let's try the first problem. So, the rated speed daw of a highway curve of 300 feet radius is 40 miles per hour. If the coefficient of friction between the tires and the road is 0.6, what is the maximum speed at which a car can round the curve without skidding? So, ato sa ikuan ang given. We have the radius R, 300 feet. Then, we have again, this is rated speed, ha? So, meaning, under ideal condition. So, let's represent this 40 miles per hour with VR, no, the rated speed, 40 miles per hour, 40 mph. And then the coefficient of friction, that is mu, is equal to zero point 0.6. And then, okay, that's it. So next thing, the required for this problem is the maximum speed. So that is V max. And then, okay, wala may requirement, no? So let's express our maximum speed in terms of miles per hour na lang. So solution. So ato to pagamiton to ato ang mga formulas nga atong lang na-derive kaganiha. So first is based on the ideal angle of banking, wherein we have this relation tangent of theta, or the angle of banking, is equal to the rated speed square over GR. Now this is ideal na condition. And then we also have the actual condition, no? We have tangent theta plus phi, no, is equal to the maximum speed square over GR. So this is the actual banking. Okay? So atong ipakita is si V max. Now, sa kaning actual nga equation, we can express this tangent phi, theta plus phi, no? We can rewrite this one using yung trigonometric knowledge. So tangent theta plus tangent phi, this is over 1 minus tangent of theta, then tangent phi. Okay? That is equal to Vm square all over GR. Now, sa ato ang given, actually, our coefficient of friction is just equal to the tangent of the angle of friction phi. So, ano matay value, no? Mao na definition, no, sa ato previous nga lesson, that the coefficient of friction is just equal to the tangent of the angle of friction. So tangent of angle of friction is equal to 0.6. So naa ta diri ah. Now ang kuwang na lang is tangent of theta. So ato na i-solve si tangent of theta. Tangent of theta is equal to the VR. So we have here 40 miles per hour. So we need to convert this one into feet per second. So we have 1 mile, that is 5,280 feet. And then naka-hour na siya. So 1 hour, that is equivalent to 3,600 seconds. This is square. Divide by G in terms of English nga unit, 32.2. And then our radius dapat naka-feet, 300 feet. Okay? So sa ubos, mahimre diri og feet square per second square. Sa upper pod matangtaang mile, tangtang hour. So feet square second square gihapon, no? So this is still feet square second square. So makancel ra gihapon. So therefore our tangent theta is equivalent to gamitan og calcu. So we have here 40 times 5,280 divide by 3,600 square divide by 32.2 times the radius of curvature 300. So the answer is 0.3563. So 0.3563. So unitless na ni siya. Now ato na siya ato na siya i-substitute diri no? So we have 0.3563 minus tangent of phi is 0.6. So minus 0.6. Not minus but plus. Then 1 minus 0.6 times 0.3563. That is equal to Vm square all over GR. So therefore, VM is just the square root, no, of GR times this one. So ato na siya i-simplify. So we have 0.33563 plus 0.6 divided by 1 minus 0.6 times 0.3563. Okay, so we have 1.2163. So 1.2163. So therefore our VM, no, kana siya, that is 32.2 times 300 times 1.21 something 63. So if ato na siya simplify, square root 32.2 times 300 times 1.2163. So the answer is 108.39. Okay, so that is 108.39. Now we're going to convert this one, no? Because ato target is in miles per hour. So this is feet per second. Okay, so our VM is equal to, so let's convert this one, no? 108.39. So we have 5,280 feet. That is 1 mile. And then this is second. So we have 3,600 second. That is equivalent to 1 hour. So therefore, our final answer in terms of miles per hour, that is 73.9, or more or less 74 miles per hour. Okay. So, naay pangutana so far? Hello, ni pangutana? Okay, so let's proceed to the second question. So, a daredevil drives a motorcycle around a circular vertical wall 100 feet in diameter. So, the coefficient of friction between the tires and the wall is 0.6. So, what is the minimum speed that will prevent his sliding down the wall? So, at what angle will the motorcycle be inclined to the horizontal? So, mo na siya figure, mo na hitabo, no? So, ambot lang og ma-achieve ni siguro at high speed. Ang pag-start ani medyo lisod. Yan na yung pagtuyok, no? So, muna siya naghigda. So, muna siya, circular ni siya ang iyahang kaninga wall, tas naka-vertical pod. So, ato iswat ang mga given. First is given si diameter, no? Ato lang iswat in terms of radius. So, the radius, if that is 100 feet diameter, so half niya na, we have 50 feet. So what else? Naatay coefficient of friction. So we have mu equal to 0.6, but it is also equal to the tangent of the angle of friction phi. What else? So wala na. Then our required is, first is the minimum speed that will prevent him from sliding down the wall. So that is the V minimum. Okay, ato lang siya express in terms of miles per hour. And then the second requirement is the angle of inclination. So, apasabot niya ni, no? That is phi. So, ako explain nun niya nganong phi man, nganong dili man ang angle of banking. Okay, so for our solution, First, if is that if mo slide ta, no? If sliding down the wall, now we're going to apply this relation. We have tangent theta minus phi. Okay? The reason nga minus is because sa kani nga figure, no? Wa man siya ingon nga sliding up the wall. Kung pa-up gali, meaning that is against the centrifugal force. Now, pa-down man, so instead of having positive, since down the wall man, so we take the negative, no? Gamito na siyang tangent theta minus phi. Okay? So, that is equal to the V minimum. So, kay pa-down man, ang pinakagamay nga speed, all over G times the radius. Unya, ato pwede ko ano nga, since ang wall nato, no, pa-vertical, since ang wall kay vertical, so therefore our theta or the angle of banking is, this is with respect to horizontal, no? Paan naman ang wall. So therefore, this angle is equal to 90 degrees. Okay? So theta is 90 degrees. So therefore, mahimo na siya og tangent 90 minus, this is angle phi, sorry, this is angle phi equals V minimum square over GR. So next yan ang tangent 90 minus theta, that is equivalent to cotangent of theta, no? That is equivalent to cotangent of theta sa inyong trigo. That is V minimum square over GR. The equivalent also of cotangent theta, cotangent phi, is the reciprocal of tangent phi. So therefore, if we take cross multiply, or if we cross multiply this, ang tangent of tangent of phi, no? So mao nang phi ang ipangita pod sa second requirement, kay phi na malang ang nabili, no? Sa pagkuha nato, sa pag-modify nato. Kay ang kuan naman ang ato ang theta kay 90 degrees naman siya. So GR over V minimum square. So since ang ipakita kay V minimum man, so cross multiply na pod, ma-arrive ta ani, no? So V minimum is equal to the square root of GR over tangent of phi. So substitute ang values, G is 32.2, the radius is 50 feet, divide by tangent of phi is 0.6. So 0.6. So ang ato aning expected nga kanang kuan unit kay feet per second. Okay, so we have square root 32.2 times 50 divided by 0.6. So that's equal to 51.8. So we have 51.8. So this is feet per second, or in miles per hour. So 51.8. So we have 5,280 feet, 1 mile. And then for the hour, so we have 3,600 seconds, that is equivalent to 1 hour. So the result is 35.3. Approximately 35.3. This is miles per hour. Okay, so muna siya ang first requirement. Now, to solve for tangent of phi, no? Di na lang sa second nga slide, solving for tangent of phi, we already know that the tangent of the angle of friction is equal to the coefficient of friction, which is equal to 0.6. So therefore, phi is just equal to the inverse of 0.6, the inverse tan of 0.6. So press AC, shift tangent, then 0.6. So therefore, our answer is 0.54, but remember, this is in radian. So go to shift mode, change that one to degree, and then press again equal. So the answer here is 30.96 or approximately 31 degrees. So muna siya ay i-maintain ng angle of inclination so that di siya mahulog. Okay? So manay bot pasabot niya na. Okay, walay pangutana? Wala na? So let's proceed to number 3. We have the super elevation of a railroad track is the number of inches that the outside rail is raised to prevent side thrust on the wheel flanges or cars rounding the curve at rated speed. So determine daw the super elevation E for a truck having a gauge of 4 feet 8.5 inches of 200 feet radius and a rated speed of 60 miles per hour. So unsa man ni pasabot aning super elevation. So since gi-define man sa to ang problem, then walay problema. So we have given first is the gauge, no? So ato la ikuan nga gauge capital letter G or ato butag track gauge. That is 4 feet and 8.5 inches. So unsa bay pasabot di aning track gauge, no? If we have an illustration, no, ato na siya illustrate on a railroad track. So no, kanang sa to train na manay kanang mga rails duha na kabuok. Okay? So ang rails na po na sila yung mga height, and then ang distance aning duha ka rails mo na siya nga to ang track gauge. So mo na pasabot ana ang distance between these two rails. Now kung mag-apply ta og banking niani, no? Again, ang banking makatabang nga dili ma-derailed ni atong train, no? So syempre ang train di gyud malikyan nga na mga magliko-liko gihapon. So therefore aton siya incline gamay. So kana siya ang first nga rail gi-incline siya. So nana day ang second nga rail, no? Still this one is the track gauge, no? Okay, so ang track gauge always horizontal gina siya nga measurement. And then ang difference sa height aning naas tumoy, no? Ang incline niya is the super elevation E. So this is now the angle of banking, not theta phi but theta. Okay? So na-create gyapon ta og right triangle wherein ang base is the track gauge and the height is the super elevation E. And this is the angle of banking theta. So unsa pa may mga given? Again, we have the radius R 2,000 feet, and then we have the rated speed VR, which is equal to 60 miles per hour. Now, kani siya nga class, no? Kani siya nga discussion. Narinig siya sa physics, no? I hope nga nakasugat mo ni ani. So, review lang po ni diri sa to part. Okay, so let's continue. Now, since kani siya kay same ra gyapon sa tong analysis kaganiha, so since kay wala may gi-state nga kanang friction, so therefore we're going to use the ideal angle of banking. So we have tangent of theta is equal to rated square over GR. Again, by this geometry, kaning sa rails nato, that is also equal to super elevation divided by the track gauge. Okay? So since what may given nga theta, so kanila to gamiton kay given ang mga velocities and radius. So therefore, solving for E, cross multiply lang, we have the track gauge multiplied by rated speed square, then GR. Okay, so ato i-multiply. So again, this is 4 feet plus 8.5 inches. So convert that to feet. So divide na to by 12. So therefore, ang result ani is in feet. Tapos, ato ang rated speed is in miles per hour. So 60 times 5,280, that is 1 mile, divide by 3,600, that is 4 hours, i-convert to second. So ang ubos, we have the value of G, 32.2, and then the radius, 2,000 feet. Okay? So again, ang ubos kay feet square na siya per second square, ag sa babaw, feet square per second square. So therefore, makancel na sila. Ang mabilin kay terms of feet. So ato i-solve. We have 4 plus 8.5 divided by 12 times, so we have 60 times 5,280 divided by 3,600, then square, divide by 32.2 times 2,000 for the radius. Okay, so the answer is 0.566. So this is 0.566. This is in feet, or if ato siya express in inches, let's multiply this one by 12. So the answer is 6.79 inches, approximately 6.79 inches. Okay, so this is our final answer. So, okay, ang takeaway ni Ani for the third problem is that muna siya ang definition sa super elevation and also the track gauge. Okay, so na pangutana. Okay, wala na. So, I'll just end na lang my presentation, no? Ako na po stop ang recording.